Hello everyone, now in this video we are just going to cover another topic that is equals to the angle of friction. What do you mean by angle of friction? Now let's see. Okay, now suppose let's take an example that there is a surface and in that surface there is a block which is fixed here and it is having a mass of m, and you are applying some forces like that. You are applying some forces of F and the object starts moving in this direction, right? The object starts moving in this direction, so obviously the friction force will work along the surface like that. So the weight of the object, that is equals to m into g, and the reaction force of that is equals to r, right? So in this case we are just going to analyze the angle of friction. Now what do you mean by that? Just if we just take the resultant of these two forces, that is the friction force as the normal reaction force, the resultant should be like that, and the resultant, let's represent it by S. So there is an angle between the normal reaction force and the resultant force, and if that angle is equals to theta, that theta is known as angle of friction over here. So what is angle of friction? It is the angle between the normal reaction force and the resultant force of the friction and reaction force, right? This is the angle present between S and R. So what is the expression of that theta? If we take tan of theta, then that is equals to the friction force divided by the normal reaction force, and we know that the friction force and the normal reaction force are related like that, right? They are related like that. So F by R, that is equals to mu. So can I say that tan theta is equals to mu? So theta can be equals to tan inverse of mu, right? Now in this case, so we can assume that, for example, if mu is equals to 1 by 3, so in that case the theta should be equals to tan inverse of 1 by 3, that is equals to 30 degree. So in this way it can be analyzed. Now let's move to the another concept, that is of angle of repose, right? So what is angle of repose? Let's see. Angle of repose, right? In that angle of repose, how to analyze that one? Let's see. Now if we just assume that there is an inclined surface, and in that inclined surface there is an inclination angle that is equals to alpha. Okay, there is a object which having a mass of m, and it is just sliding over that surface. It is just sliding over that surface in this way, right? It will happen if you take a slider and an object is fixed on it, then you will see that the object is sliding over that surface. Now for that object there is a weight that is of m into g, and it is having the horizontal component as mg cos alpha, and the normal reaction force should be like that. The vertical component of the weight should be equals to mg sin alpha, right? And if it is sliding in this way, then the friction force should be like that. The friction force will work in the opposite direction now. So that's why what I can write down here, that the normal reaction force is equal to the horizontal component of the weight, that is R equals to mg cos alpha, right? And in this case that the friction force, that is equal to the vertical component of the weight, that F is equals to mg sin alpha, right? So this is our expression number 2 and this is our expression number 1, right? Oh sorry, you can do 1 and 2 as well. So if I just divide these two expressions 1 and 2, then what will happen? That is F by R, that is equals to tan alpha. So in this case, one funniest thing is that F by R, this is the ratio. So in that place we can write down that it is equals to mu. Then the mu, that is equals to tan alpha. So in the previous case also, that F by R, that was is equals to mu, that is equals to tan theta as well. So from this expression it is very much clear that the inclination angle alpha for this surface, that is equals to the angle of friction. That means the angle of friction is equals to the angle of repose in this case. In this case also, if you take the resultant of them, you will see that the angle of friction is equals to alpha, right? So after this concept, we'll just analyze some new things that we have not studied in the class. What are the things? Let's go for it. That is that case number one. Case 1, let's suppose assume that the object, I hope we have studied now. Suppose we are applying a force like that. I'm just giving you the recall of that. There is an object which is having a mass of m, and we are applying some force like F. We have represented in class that the force should be like P, right? You can prefer anyone. You can represent the force as P or F, whatever. Now if the force it is working with an angle of theta, in this case here theta is an arbitrarily taken, okay, it is not a kind of angle of friction, okay. So in this case the force is applied on that object with an angle of alpha, so the horizontal component of the force, that is equals to F cos theta. Sorry, in this case the horizontal component of the force, that is equals to F cos theta, and the vertical component of that, that is equals to F sin theta. It is a one type of pull force, right? So the weight of an object, that is equals to m into g, and the normal reaction force, that should be equals to r. And if it is not moving, suppose if it is not moving, that means the applied force is very much less than the friction force. This is your applied force and this is the friction force, and if the object is not moving, that means the F cos theta is very much less than the friction force, right? So I can do one thing, that F cos theta is very much less than of mu mg, right? That's why it is not moving. So this is the condition when an object will not move after applying the force like that. So what is the next case? The next case should be the object when just starts to move, right? So let's analyze. This is the object which is having the mass of m, this is the weight of that, you are applying a force like F, and this is angle of theta, this is your F cos theta, right? This is your F sin theta. So this is the surface, and if the object, after applying lots of forces, if the object starts to move, that means the friction will present like that. So in this case the normal reaction force should be in the upward direction. So what are the two expressions that we can get over here? So in this case the reaction force plus of F sin theta, that is equals to m into g. This should be your first expression, and the second expression, that should be your F cos theta, that is equals to the friction force. That's your expression number 2. Now what do you know that's a relation between the friction force, that is equals to mu into the normal reaction force, right? So we'll just substitute all of the values in this expression. So I'm just substituting all of the values in that expression, then I will get F cos theta, that is equals to mu multiplied by mg minus of F sin theta, the value of r, that is equals to mg minus of F sin theta. I'm not just doing the calculation here, a line should be included over here, that r equals to mg minus of F sin theta. I've just substituted it directly. So here F cos theta plus of mu F sin theta, that is equals to mu mg, right? That kind of expression you will just get. Now let me slide it down. Now F should be taken as common, and it should be cos theta plus of mu sin theta, that is equals to mu mg, right? So what the expression of F, that is equals to mu mg divided by cos theta plus of mu sin theta. So this is the case when the object just starts to move, right? Now we'll analyze the case of acceleration as well in this case. Now what about the case 3? In that case 3, we'll just assume that there is an object which is having a mass of m, and we are applying some force like that. It is having some angle of theta. In that case the horizontal component should be F cos theta, the vertical component should be F sin theta, and here the normal reaction force should be equals to r. The weight of the object, that is equals to m into g, and if that object is placed over a surface, there the friction will be present over there. And we are just assuming that we are applying the forces in that case, and the object is in acceleration. The object is moving in this way and it is in acceleration. That means your applied force is very much greater than the friction force. That means the net force will get that F cos theta minus of F, that is equals to mass into acceleration, right? This should be your first expression, but let me modify it. So F will be equals to F cos theta minus of m into a. This is your expression number 1. What should be the next expression? That is of r plus of f sine theta, that is equals to m into g. So r equals to mg minus of f sine theta. This should be your expression number 2. So in expression number 1, and in expression number 2, we have just got the values of the friction force and the normal reaction force, right? Now just let me slide it down, then we'll just substitute all of the values in the given equation, that the friction force is directly proportional with the normal reaction force. That means the friction force, that is equals to mu into r. So here the friction force, that is equals to F cos theta minus of mass into acceleration, that is equals to mu into mg minus of F sine theta. That kind of expression we'll get over here, right? So here in this case, the applied force, I need the value of that applied force, right? So plus of mu f sine theta, that is equals to mu mg. That kind of expression I will get. So after solving, I'm just taking a step jump, okay? So cos theta plus of mu sine theta, that is equals to m into mu g plus a, right? Now the applied force, that is equals to m into mu g plus of a divided by, again I have to slide it down, divided by cos theta plus of mu sine theta. That kind of expression you will get for the case of acceleration. So up to that portion we had just completed in our previous class, okay? So the next topic we are just going to start in the next class, but before that I will give you some numerical question based on that, and let's see whether you guys are able to solve that or not, right? Okay, and if you feel any doubt, then please ask me.